Welcome to the Mantra version of lighting and shading the fractal mineral. Let's start by creating the top light. Control clicking on the area light. Maybe less intense. Let's go to the side view. Control click. And this is going to be our blue light. Maybe less saturated. And maybe less intense. Let's go to the other one. The red light, control click. It's going to be the red light, less saturated, also less intense. Let's look at it from the camera. Seems nice. Distances are okay. I'll increase the size of the main light and I'll rename all these. I'll hold Alt, click A, the letter A. So if you want to quickly align your nodes, just Alt A, click and drag down, and they'll align vertically. Next, I'll rename these. So this is going to be my main, this is going to be my blue, and red. I'll just increase the size of the red one to 2. I usually don't like using normal light intensity to area. Not really my thing. It's not as important for these ones, but I might need to increase the intensity on these, since they're further away and smaller. But let's check it out with the render. Mantra node. Rendering, let's go with physically based rendering. For the settings, I'm just gonna set these to be quicker, 6, 0.02, and here on the limits, I'll just have 1 to see the at least one bounce within the shape itself. And that's it. Let's go to render view, Mantra, and let's choose the camera, update, render. Let me check the resolution. Let's start with something smaller for now, just for lighting purposes. First comment is that the lights are too saturated, so I'll go here to the blue and desaturate the blue a bit more. Maybe even less. Yep. Maybe increase the intensity of this light, or maybe increase the size to 2 as well, which will also increase the intensity. Yeah, this seems better. In terms of hierarchy of light, I'm going to keep the main light as being the strongest, the blue light as being the second strongest, and the red one as being just complementary. And I'm going to leave the saturation values for this one. So the lighting is for now approved. Stop. I'm going to create a material network, and in here I'm going to create a principled shader. We'll follow the same idea or the same logic, which will be to first create the dark material, create the dark metally material, and then create the other one. So I'll use the triplanar again. On this triplanar, you can, so it's not as simplified as for Redshift. You have a bit more control, but you do usually have some more work. So I'll copy this parameter and I'll paste it. Paste relative references here, paste relative references here. I don't want this turned on. And the scale, I'll do the same thing. So copy parameter, paste relative references, and paste relative references. So this way I just need to worry about the x-axis, and that will reflect on all the others. I'll choose my texture. I'll work with 4K for now. Accept. Connecting this to the base color. Before I do that, I'm always afraid that this value is going to actually multiply the texture, so I think it actually does multiply, so I like to have it white, just be safe, and apply it to the material. let's turn off the reflection activity. I don't need this for now. Go to render view and render. We'll probably need to adjust the scale. The texture is showing very light, very light. So if we compare this with the texture that I initially had, let me show it to you. So this is the texture that I'm using, and it's completely off. Might be a gamma issue, so I'll just use a color correction here and make sure. If you want to correct the 2.2 gamma that might be applied when it's actually not needed, you can just apply a gamma of 0.454, which will do the inverse. So we should have something better now. One nice thing about Mantra is that you can actually drag and drop directly on the render. It will recognize, and you can also drop maps. So if you just want to look at the texture, I think this is better. Now I will definitely adjust the scale. I'll copy this value, copy parameter, and paste it here. Paste relative references, let's say 0.5. Yeah, maybe even smaller, 0.3. I think 0.3 might be an interesting value. Let's look at it with the material. It's looking good. Now, in terms of adjusting the material, we need to have our metalness higher, metallic value around 0.9. This is closer to what we had on the previous one. And let's use our roughness channel or our roughness map as well. So I'll switch this to roughness, accept. Okay, so this is our roughness map. A lot of areas have high roughness values. So what I'll do is I'll convert vector to float. I'll grab any of these and do a fit range. Apply it, and I want the maximum roughness to be around 0.5 and the minimum around 0.1 or 0.05, something like that, just so we don't have absolute values. This should give us a more interesting look. Connect this to the roughness, apply. Let's switch back to full HD so we can have higher detail. Yeah, I think this is a really interesting look. Really nice tones here. Now the next thing I'll do is apply the displacement. So for the displacement, we're gonna grab these two. We'll use displacement along normal. Displace along normal. This will control the amount. We'll have to choose our height map. You can have a look at the height map by itself. Okay, this is our height map. Next, what I'll do is I'll need to, as you can see, this is our height map is going from 0 to 1, and I want the amount to go from negative values to positive values. So I'll do a fit range here, and I'll say I want minus 0.5 to 0.5. As before on the Redshift version, you'll see that this way we can get some pushing in and some pushing out happening at the same time. Now we'll need to collect these shaders. This is going to be our shader 1, the displacement information. We'll need some output variables here. These output variables need to be set up for displacement. Output position and normal, shader 2, and then we need a properties. Let's edit the user interface for this one. Render parameters, we search for something called bound. And here under shading, you can see displacement bound. This is what we need. Apply, accept. And now we connect this to the scale of this displacement. So it should be around 0.1. Let's see. So we copy this, copy parameter, paste relative references times 0.02, 1.02, so it's slightly bigger than the actual displacement. And here on the collect, we'll throw this one in, and let's apply this, and let's see how this looks. It's looking good, a bit too strong. I'm gonna lower the intensity here of the displacement. The scale is gonna be 0.05. I think this might be a bit too much. Yeah, this is better. 0.05. Sounds good. Yeah. Okay, we got the dark metal and the displacement set up. Now let's work on the other material. Let me pull these down along with this. And we'll just create another principled shader. I'll use exactly the same thing as before, so we'll use this color correction here on the base color. Again, switching this to white, disabling use point color. Base color, and I'll use this for roughness. And the difference is that this one won't be as metallic. So here in the metalness, I'm gonna go with 0.6, and we'll add some emission. The emission color is a red of 0.5 saturation, and here the emission intensity is 0.6. Another advantage of Mantra towards Redshift is that this is actually going to work. So while in Redshift you don't get the emission actually lighting the surrounding objects, in this case you will notice the influence on the surfaces, the surrounding surfaces. I'm gonna hide this one, minimize this one, and here let's have a look at how this is working. Okay, it's working. Now, next step, working on the mask for us to combine these two. Let's get our attribute, our area attribute. And we'll also, let's have a look at the area attribute. Let's try to apply it and have a look at it. See if everything's okay with it. Not visible. Let me try do a vector, a float to vector. Yep. Okay, converting from float to vector, it actually allows us to have a look at this. Now, one interesting thing that we could get is probably use a ramp for this, ramp parameter, and use a ramp in between these two and do a spline ramp. Make sure we invert these. Let's have a sharper transition. So we only want the small pieces to actually show as red. This ramp, the distance between these two is going to determine how much of a gradient you'll have. Maybe smaller, maybe even smaller. Let's do a constant interpolation, constant, and here delete point. Yeah. Okay. Now we have a very sharp transition. It might be too sharp, but it's easier to control. This one can stay here, and then can just define these values. let's see how this looks. Now the next thing we need is we were also using curvature to add a bit of extra detail to the corners. So let's get a curvature. And as for the curvature, let's see what we can get with this curvature. I'm gonna just render out this region. I held shift, click and drag to define a smaller region, render region. Okay, so a bit noisy. We want these edges definitely. Let's try and play with these values. Concave scale, maybe this at 0. Not really worried about the concave scale, so this looks good. Convex scale, maybe let's play with the convex bias. Yeah, more towards the other side. Let's leave this at 0.5. What else? Oh, mean, Gaussian. Let's try different ones. Nope. I'll use mean, space 0 to 1. Yeah, for this case, in this case, I really just want 0 to 1. Let's try reducing the scale here, 0.5. Get it to be thinner, 0.2. Yeah, more like this, 0.1. Definitely more interesting, this one. So we'll work with this. Let's just do a fit range or a ramp. I can actually use a copy of this. See how this looks. Of course, in this case, we don't want constant. Let's set this to linear, and let's set this to linear, and let's set this to linear. Great, so this is gonna be inverted. Let's do black to white. This should give us the what we had before. We have this, and with this, I'm not seeing anything. Let's call this ramp 2. Yep, that was the problem. Okay, so we want these areas to be black. Great. Okay, black and white. Now, the other map, which is the main one, is this one. And basically, I just want to subtract some of this information from the other side. And so it's not a multiply, actually it's a we'll subtract. Let's use a subtract. Gonna be this minus this. And okay, so this is what we were going for, but we do not want this to be completely black, because otherwise, if it's completely black, it's just going to show 100% of the dark material, and that's not what I'm going for. So all I need to do is here on the ramp, I just need to lower this value. Okay, it can't be 1, because 1 is going to give me at least 0. So I want less, an in-between value. Okay, and that's better. Now we've done our mask. We have our 2 materials and we have our mask. I can now stop the render, delete this one and this one. We're actually going to be using the output of this. This is just for visualization purposes. And now we need to mix these two. To mix, we'll use, as the name implies, a layer mix. Let's use a layer mix, layer A and layer B, and layer B is going to show wherever the alpha is 1, and we'll use this. Let's have a look at the layer mix result, render. Okay, perfect combination between one and the other, exactly what we were going for. All we need to do is include the displacement on this. Now here we get to a tricky part. Usually what we would do is we would unpack the layer, output these variables as a surface, connect the F to the F, and then we would just, here on the collect, we would connect this shader instead. Now the problem is that along from this point to this point, we lose emission. I'm going to show you the result of this. Don't really like this transition here, so I'm gonna adjust my ramp. Instead of having a constant interpolation, I'll have a linear, but around those values, but so that this doesn't look so weird. Now, the result of this collect is this. Like I said, we lose the emission attribute, or the emission information is not affecting anything anymore. It might be that there's another way of doing this, but I'm going to show you what I did to solve this, to go around this problem. But first I'm going to go here and make sure that this is here with an linear interpolation, and that should be better. At least we have a very small ramp. Now, regarding the displacement, including the displacement on what we already on this solution, which looks perfect except for the displacement. So we need to have this plus the displacement. Let me just remind you of what we had, and we will be able to have a look at the new transition ramp. Yeah, much better, much better. So this looks great, it's just missing the displacement. And the solution I found was the following. I'll delete this, don't need it. I'll delete this, don't need it. And I'll delete this, I also don't need that. So it's actually simpler than the previous method that we saw, in some aspects at least. See these two here, base normal, V displacement. Let's just connect these there directly on both the materials that we're combining. Okay, base normal, we connect to normal, and displacement position, V displacement. And that's it. The only thing we need to do is here on the principal shaders, on both, on the displacement section, as you can see, there's the displacement boundary that we were adding on our properties node, and this time we just need to connect that to this scale. So I'll copy this parameter and paste relative references. Again, I'll multiply it by something bigger, slightly bigger than 1, and I'll just copy this expression and paste it here on this one as well. Okay. Next, we just press render. Now we should see the final result with the proper displacement, proper materials, with emission, and everything should be working together. Great. Okay, so you can see now we have proper displacement, proper emission. You can definitely see the emission lighting here. This isn't just reflection, okay? This is some actual diffuse contribution coming from this material. And it's good to go. Now what I'll do is, since render isn't as fast as Redshift and my machine only has 8 threads, yes, I know it's sad. What I'm gonna do is I'm gonna stop the recording. Let me just go to Mantra and show you the final adjustments that I'll make here in Mantra. So it's not gonna be extremely high quality render, but it should be better than what we're seeing here. I'll increase the diffuse limit so we can have at least 2 bounces. Barely gonna be visible still, but something I think makes sense. Here I'm gonna increase the pixel samples to maybe 5. And here the minimum ray samples 2 and maximum ray samples to 8 or maybe 10. And 0.008 on the noise level. I'll also enable depth of field. I'm using the same camera as before, so it already has here on the sampling, this value, this crazy value for the f-stop, but it's because of the distance that we're at and the scale of the object, so it has to be this, otherwise we won't see anything. Let me just I'll just choose an output and I'll show you the final render, and that's it. I'll stop the recording now and I'll be back in a moment. So render is done. I've applied the same post-production look to the Mantra render, and this is the result. Of course, it takes a bit longer. It's a bit more complicated to set things up, but I really like the look that Mantra gives you. And to give a few words about Mantra, it's probably one of the most powerful renderers out there. And it's just, the only reason it's not my favorite is because it's just not fast enough for me to be able to produce actual work. I don't have a powerful machine either, so that doesn't help. Redshift with GPU rendering really makes things more viable for me as a freelance artist. But yeah, the look is really good. I'll show you the Redshift version. So this is the Redshift version, and this is Mantra. Mantra versus Redshift. Redshift, Mantra. So it's pretty close. It's slightly different. Of course, one of the differences is that the mask that I'm using, I have a lot more red here in the Redshift version than I have on the Mantra version. But the overall look is pretty close, and yeah, I really like working with Mantra. It has a lot of flexibility. Redshift, on the other hand, is more practical, more straight to the point. It makes things easier if it's simple things, simple tasks that you have to do. But yeah, the speed is what makes the difference. Okay, so hope you like this one, and see you on the next.